Verizon, AT&T, and T-Mobile are the big three cellular carriers in the United States, and they all want just one thing that only the Helium network can offer. Welcome to The Hotspot. I'm your host, Arman Dezfuli-Arjomandi. Today's guest is Russell Frum, an engineer with over 7 years of experience deploying network coverage and optimizing systems for huge US carriers like Verizon Wireless and US Cellular. I've been hoping to get someone like Russell on the podcast for a long time. 5G is a complicated subject, and I've been wanting to learn from an expert like Russell about how 5G networks are built and paid for, what exactly they are to begin with, and how Helium 5G fits into them in the grander scheme of things. It turns out that Russell was the perfect person to answer these questions and more, and I highly recommend listening to this episode all the way through, especially if you're interested in deploying 5G hotspots. You will come out far ahead of the competition at the end of this episode with a solid understanding of what the cellular market needs and how you can provide it. So I won't keep you waiting any longer. Here's my interview with Russell. Russ, welcome to the show.
Thanks, Arman. Happy to be here.
It's so exciting to have you here. I think you bring a different perspective than anyone else who's ever been on this show before, with tons of experience in the telecom industry. So I'd love if you could share a little bit about your background. I think you have a lot to offer our listeners here. Tell them a lot of things that they didn't know before.
Yeah, absolutely. Yeah, and this is part of the reason why I'm so excited about Helium. So my background is I worked in telecommunications. I mainly worked for Verizon Wireless, where I deployed hundreds of 4G cell sites and basically built the network in the northern Midwest. And then as I went through my career there at Verizon, moved on to being a network engineer in charge of multiple data centers in the Midwest. And then finally, before I left, the first time I left the industry, built out their cloud platform for the worldwide Verizon cloud. After that, I moved into cybersecurity and then came back to telecom to work at US Cellular, where I was a network security engineer protecting them basically from hackers around the world. I've been in the industry quite a bit. I was at Verizon Wireless for 7+ years. I had a variety of different roles. I started out as like a lowly, what they call, ops technician, and then worked my way up to principal engineer. So I got to see the business from a variety of different ways and became an expert in 4G networks, how to build them, how to provision them, and deploy them out. So to me, a lot of like 4G and 5G terminology, because I was exposed to it for years and trained on it. And I actually, provisioned the actual equipment itself. I would log into a machine and there's 20 million people with their cell phones running through there. I'm like, whoa, okay, definitely don't want to make a typo. I've had a lot of experience in the industry, and that's why I was so excited about the Helium project and got into it, as quick as I could, and became basically a micro network operator here in the Midwest, where I help people mostly in Wisconsin, in Minnesota, Michigan, really get started and explain it to them, and also speak at conferences. I got a big one coming up in April called CypherCon, where I'm sharing and really trying to evangelize the Helium network and Helium community and break it down so that more and more people get hotspots to join the network and grow it.
It's really exciting that someone with your experience, who's basically a veteran in the telecom industry, would be interested in Helium and excited about it. I don't know if all of us understand why you'd be interested, and I'm hoping you can help us understand from your perspective what's so exciting about it. And then also on the flip side, help us understand what's so exciting and important about this existing technology that we all take for granted, right? We all have cell phones. Every single one of us has a phone. We use them constantly, and they're connected to these cellular networks. And at the end of the day, we don't really think much about how that actually happens or what it means to have a cell phone in the connectivity sense. It's all sort of obfuscated from us, which is great from a consumer perspective. But when you're trying to understand the structure of everything, it can be confusing where to even begin trying to understand something like cellular technology.
Oh, yeah, absolutely. I agree. It is extremely complicated learning all the terminology and lingo and how it works. And it's funny, I agree from working in the industry. Everyone takes their cell phone for granted until it stops working. Everyone loves their cell phone until it's slow. It doesn't load. Used to be, the prime members when I started in the industry was you can't get a phone call through or a phone call drops. Now it's all data. So going back to, why am I so excited about this? Well, this kind of comes to, a big reason why I think, Helium is so impactful. I think that it is such an energizing and, amazing change to how we communicate. This is like, I would just put it a couple notches below, like, basically the invention of the internet. It's that big of a deal. The reason is today, when you want to get data connectivity on your cell phone or on your hotspot or on your laptop and go around the world, you've got to go through the major telcos, usually in that country and area. The big thing why I'm so excited about it is that the primary purpose of the internet was to share information and to help people learn. That was like the grand vision when it all started. And I think the grand vision of Helium is to create ubiquitous, affordable wireless service everywhere in the world. Without, without just thinking about how much profit you make, we're really worried about, how to get this connectivity out there. And the amazing thing about it that really surprises me is that it's actually sharing the revenue with normal people, that can actually just buy this hardware as long as it's from an approved manufacturer and get it up and running. It's very simple, very easy to do, and you can start earning enough income. I mean, but with most of the hosts I work with, they're paying their internet bill with it at a minimum or more. So it's exciting. Like, I would never, ever think that the carriers would come up with something this disruptive to their existing technology on their own. So that's why I'm so excited about it, because it's going to make, I think, in the long run, the next 5 to 10 years and longer, much more affordable data transmission and a lot more reliable data transmission. And the way that the Helium network works, I love their community and their founder, their technology, because they're really focused on making it easy and simple and ubiquitous and sharing what they earn. Like, if a traditional telecom startup would start a new carrier and keep it all themselves, they're not going to share revenue with anybody. It's their revenue. But here, they're just open about it, and it's all transparent on the Helium Explorer. It's just amazing. I think it's a huge step forward, like an exponential step forward in the technology that we're using to communicate with each other and their approach to it. And I think it's going to take years, but eventually this will be something that everyone will be talking about everywhere in the world that don't know about it already, about how affordable and ubiquitous it is. And just the exciting news we're getting already about partnerships is showing we're in the right direction.
Wow. Well, I think you basically put into words the vision of Helium quite well. This wireless service, it can be democratized. It's just that no one has come up with a model until Helium. The price of starting a new carrier begins in the billions. Even if you apply, traditional quote unquote crypto to this problem and try to create, like a DAO to fundraise and buy spectrum or whatever, it's still going to be like out of the reach of the biggest versions of that type of crowdfunding project that have even existed thus far. I really want to learn a lot from you about why this is all the way it is. I think it's going to be very instructive to start way at the beginning, which is, what is cellular service, right? Like, I have this phone. I know that I can make calls and texts. I know I can browse the internet, watch YouTube. And I know that it kind of basically works wherever I go. But what is it doing? Like, what is this phone doing? How does it get connectivity? And what role does the telco play in providing that connectivity?
Yeah, it's really amazing behind the scenes, because it just works for most people. Like, I don't really care how it works. But what it's actually doing in the background is your phone is talking over the radio, kind of similar to what we're doing now with LoRaWAN, to cell sites, very similar to our hotspots that we have now, or microcells. There's different terms, some people are using for them. And like it's sampling the air like 1,000,000 times a second, saying, all right, who can I talk to? How strong is that signal? At the same time, that little chip that's in it, that little SIM card, really uniquely identifies it and is used to really authenticate you to that network and say, okay, I know who I can talk to and transmit data to. So when you go and load up your web browser, and let's say we're going to go to google.com, we're going to start a search. Your phone's going to, it's going to go down through the stack, go down to what they call the baseband of that phone, and go, I have a request for this data. It's going to quickly survey who it can talk to, pick the strongest / best one, and that data is going to go to that cell site. And then that cell site's going to go through, actually wired. So that's that first hop, that wireless hop to the cell site. After that, it's going to be wired. Usually it's going to go over dark, what they call dark fiber, like your fiber internet to your phone, back to a data center. So you think of like the big Google data centers. They look a lot like that. There's different terms in the industry. for them, but it's basically data centers. And then finally, it's going to drop off on the public internet, just like your home internet. And that's, on a super high level, how your phone is awake. It's always awake. It's always talking. Even when you're sleeping, it's talking and going, I got data transmit, especially with how many apps we have and how many updates we have these days. It's always talking. That's really what's that's a snippet of what's going on in the background. And the carriers spend a huge amount of time and money and resources making sure that when you want to do something, when you want to even watch this video clip on YouTube, it is as fast and reliable as possible, while also being as affordable as possible is another big one, because they are not public companies. They're private companies. They're very profit motivated. They need to have a return to their shareholders. So that's a big part of their calculations for how they build the network and why they build it the way it is today.
So you say that they connect to these cell sites. What exactly is a cell site? I imagine that most of us go through our lives not even having noticed or paid attention or even recognized a cell site, and yet they're everywhere. So what do they look like?
Yeah, it's actually kind of funny. Like on the Helium forums, people are like, I never noticed that there were so many towers around me. Until you start looking for them, they seem like they're invisible. So here's what a tower is. So what it typically is going to be a metal pole that goes up, I'd say, at least 60 feet in the air. The exact height will depend on a variety of factors. And then what you will see is these these large rectangular, and I call them antennas, like that's what they are, but these large rectangular radios / antennas that are going to be on there, and they're usually going to be in sets of 3. So let's say you have a pole that's going straight up, and then about this up, that's where you're going to see these little antennas. It's just like my finger. You'll have one on this side, one over here, and one over here. We call that a typical 3-sector design to cover all the areas around it. And they can be at different heights. The reason why they're at different heights is because they've tuned their network. For instance, maybe Sprint wants to be lower, and other ones want to be higher. It depends on the coverage that they want. Also, a lot of these radios, they can remotely control them. So if you watched it like all day, or you watched it for a couple of weeks or months, you'd actually see them move a little bit and tilt a little bit remotely, which is very cool with all the work they do. So that's basically what you're looking for, is something that's taller than what's around it. And just look for those 3 little kind of rectangles around it. That's going to be a cell site. There's also free apps you can download as well that will help you show on a map which cell site your phone is actually talking to live.
So these cell sites that you're talking about, up high, outdoors, on a pole with 3-sector designs, huge, right? Like, what's the difference? Just to bring Helium into the conversation for a second before we go later into detail about how Helium fits all into this. What's the difference between these cell sites and what is available right now for Helium 5G? Because it looks very, very different, right? You're not talking about an outdoor pole. This is like a little indoor, basically a box that you put somewhere, and that is able to offer service in an indoor area. So what are those cell sites that the carriers deployed called? And then how does the Helium 5G indoor sort of experience fit in there?
Yeah. So the term for those in the industry is macro sites. Macro meaning it covers a wide area. And typically carriers, if you go to the bottom of that site, what you'll see is typically a little brick, we call it a shelter. And that's a little brick building that houses the network information. And I mentioned dark fiber earlier. The dark fiber, basically what it's using to get that data out to the internet, it's going to go to that shelter as a hardwired connection. And usually it's redundant. There's going to be 2 connections for it. The carriers are really big on redundancy. So that's when you definitely know you've got a cell site. You see this little kind of brick or steel building at the bottom. You see a big tall tower. You see sets of these 3 radios at different heights. You're like, you've definitely got a macro cell site. What we have at Helium right now is very, very different than that. And while I would love to have one of those, I probably wouldn't be able to afford it or justify it financially, just for the payment to have a site like that. So right now, what we currently have released with Freedom Fi is an indoor CBRS and basically antenna that runs on LTE. And that is a bit different. Number one, it's indoors, so you cannot, it's illegal to install that outside. Not outside of that side, designed to go outside. The second thing, it's only one of them. I mentioned we normally have 3 of them. Well, most people, as far as I know, only have one of them. So you got to pick your favorite direction that's probably going to have the most traffic, most people, most cell phones, most devices, and point it over there. So what we have now is very different. Now, of course, base cells announced that they're going to be coming out with some outdoor antennas. And those are very different from what we have today, is that you can actually put those outside on a pole. From what I see, it looks like those are going to be flat panels. So those will cover, maybe 120 degrees. You'd still need 3 of them to cover all the way around whatever your location is, probably your house on the roof. On top of that, you can't install it out there without actually having a license, what they call a CPI license. So we're very, very lucky in the United States to have CBRS spectrum. That is really what allows any type of LTE, 4G, 5G technology to exist on the Helium platform. And it's a huge gift that we have here that we're lucky to have. And because of that, we're allowed by the FCC to actually put these out and use CBRS spectrum. My memory is, I believe it's band 28 on your cell phone. So if you want to get technical and Google it, you can be like, let's model my cell phone. What bands does it support? If it supports the CBRS band, it will work on Helium. And, Freedom Fi kind of walked people through that with the kits that they sent out. So that's, where we're at now, is we just have these indoor ones that cover, one focused direction. It's been announced that we've got outdoor ones coming in, but you need a license to legally install those. So you don't want to get in trouble. Definitely want to follow that and get that. Now you can get that training. You can Google it, get that training, Google it. It's about $600 to get it online. There's a variety of companies that are out there, CommScope, you can Google it. But you definitely want to have that before you install it outside. Reason being is safety. Safety and licensing. They do want you to have some idea of what you're working with, the exposure that you have, the power levels that you're working with. Those big macro cells, they put out a lot more power than what we're putting out here. We're used to like LoRaWAN modules, and those are what is advertised. Those use as much as a light bulb. They're using hardly any power at all, and I'm amazed how far it goes. I'm going out 20 miles from my house. It's amazing. I'm not expecting that from LTE. So even on a CBRS band with very little other people using that spectrum in the area yet. So mainly being that I'm not expecting that amount of power. Now that gets down to the antennas that you're using, how you want to focus it, et cetera, as well as limits on the power that you can use. But that's, the state of where we're at, and where I'm hoping and, where I'm seeing we're going with this year is that we're going to have a lot more vendors available. They're going to have equipment that you can buy. We're going to have lots of antennas to pick, and they're going to be at different power levels. So basically, you're going to be able to, on your own, if you have the license, install it yourself, build one of these, a smaller version of these macro cells. And this is where I bring in kind of a new term that was a very big deal in the industry about 5 years ago, called small cells. And these are the other cell sites that you probably don't see that are really invisible. These are really small ones that are typically put on like your electric poles. Most people don't see them. They're hidden usually. They're colored green. They might even put like fake branches around it if they try to make it look like a tree. Small cells are not like those macro cells that cover huge areas and want to cover as much traffic as possible. Small cells are meant to be just these little cell sites that just cover a small area, maybe even just a block of houses with high-speed, reliable internet access through the carrier.
So these macro cells, how many people do they typically cover? Are we talking, hundreds of people or thousands or tens of thousands? It sounds like there's a lot that goes into them, not just the radio and the backhaul, right? The fiber lines. You said there are redundant fiber lines that go in there, which must be very expensive. I'm sure there's also redundant power, backup batteries, and of course, whoever deploys that site has to lease real estate or own real estate in order to build it there. So there are a lot of costs that go into these things. How much coverage are the big telcos getting out of investing into those macro sites?
It can be thousands. Typically, it's hundreds is what I saw in my experience. But it's not just the number of devices. It's how much are they talking? How much bandwidth are they actually requesting? It's a big part of it too, because you can have one user who's trying to hog it all and use a massive amount of bandwidth. Now, there's other things I won't go into that the carrier does to kind of minimize that data and cache it. But basically, people who are using more data, they can take the spot of other cellular devices. However, they do. There's mechanisms within 5G to make sure that it's as fair as possible and everyone's able to use it, unless we're in an outage scenario where it's completely overwhelmed. Let's say there's a national emergency or there's way more people there than expected. then there are ways to get priority that are built into the cellular network where you're allowed to bump for. But up to 4G, it was very fair. Everyone, as long as you were near that cell site, you got pretty much the same service as somebody right next to you. 5G changed a little bit with what they called network slicing, to where they can change the service levels. You can be right next to somebody and they can have a completely different experience, and you can be faster or slower versus a traditional 4G site. So the answer is typically thousands to hundreds, depending where you're at. The other thing is area. It's not just how many people you can cover and how much bandwidth you can get through there, but what type of area. Like you take a macro cell and you put it in a more rural area, you can cover, a lot more. They're going out wide with a 3 sector. You can cover a lot more area. Typically, you're going to go out, tens of miles more. Where if you put a cell site downtown, you might only cover a block. So it's a huge difference. So there's a lot that goes into planning these and tuning them so that they're putting out the right power at the right place and the right coverage so that everyone who uses it has the best experience possible.
So there's a lot that goes on in the back end. There are a lot of field technicians out there who need to deploy these sites, maintain them, make sure that they stay up, and basically make sure that all of the data and power that's flowing into there is uncongested and reliable. This is all very expensive. So I want to kind of get into what the cost model is for the carriers. Like, what is their business? How does this make sense for them to invest all this capital into building these huge sites? Why do the carriers spend so much money? I mean, if you look at the capital expenditure of these carriers, it's in the billions to tens of billions per year. What are they spending it on? Are they spending it on like building the actual towers themselves, maintaining them? What are the costs there? Why is it so expensive?
Yeah, there's a lot of things that go into the cost. I have kind of my own opinion, which I'll leave to the end based on my experience working in the industry, where those costs could be trimmed more. The majority of the money is first spent on the rights to use wireless spectrum. So they get to use certain frequencies that talk with your cell phones. That's where they first spend the most. Next is actually getting the rights to put up those sites, whether they're small cells or macro cells, is actually getting those locations. That's something they've been doing for decades. They're very good at it. And also negotiating with people who own those sites to make sure the costs are as low as possible for what they're doing. And to make sure they get about the radios and network equipment, the antennas, make sure that all that is in and is put in most affordably as possible. They also have to typically, even though if they lease the area, they have to put the shelter in on their dime, improvements for there, as well as pay. They might have to trench fiber into there from whoever they can get to come in, especially in a rural area. You might have only one choice. So a lot of costs come in on the physical build out. The other costs come in on operating it. So they spend a tremendous amount of resources on people and staff that monitor the network. Now, a lot of this has been automated in kind of the 5G era. In the 4G era, it was still automated, but you had a lot more engineers reviewing all the data. With 5G, they have automatic, what they call SON technology. Cisco has equipment out that does this. They call it self-optimizing network. So they basically allow some amount of we'll call it a little bit of AI to tune and move radios and power levels a little bit within the network. The majority of the cost is sunk into that capital expense of building out all that equipment, building out those data centers and those sites and getting rights to do it. After that, it's on the people that actually run the network and bring it up. As well as the retail stores are a pretty significant expense as well. So that's where the costs start coming in. And being in the industry, the real big thing that you want to focus on is what is your cost for your subscriber. The more profitable you get, you got to break it down so that, for all the retail stores, for all the engineers, for all the macro sites, the small cells, the data centers, what is your actual cost per gig delivered to the user? And bringing that cost as low as possible, really low. And that's where I think there's a huge opportunity for Helium to help the big carriers kind of hit the target number that they want to hit.
So what are the challenges in bringing that cost down? Couldn't they just, recruit people in an open source way to sort of add cell sites onto the network, kind of like Helium is doing, and to provide the equipment, just say, hey, here's the equipment, go buy it. Anyone can come participate, and suddenly everyone who's participating is reducing our costs for, the site access, for the equipment, for the people, the maintenance, and they already have the retail stores. So that's already, like a sunk cost for them, right? They're not going to need to add more retail stores if there's more service. So what is preventing the carriers from just doing this themselves and saying, hey, we need a little bit of help building the network. We'll compensate people who are willing to add on cell sites to this network. Why is Helium an attractive option to them, whereas bringing people in directly is not an attractive option?
Yeah. So that, the most partnerships they've done is with roaming agreements and working with what we call rural carriers or smaller carriers outside of the big three. The big three are, Verizon, AT&T, T-Mobile/Sprint. The idea of sharing their network with people who aren't engineers is like blasphemy. Like why would you ever do that? Because they lose so much control. I think it would never get through any type of approval or committee normally. The second thing is that what the big network operators that you're thinking about, they don't build their own equipment. They buy it and deploy it. They're really, really good at deploying equipment, provisioning it, and running it. What they're not typically doing in-house, and what they've never done in-house so far, is actually build the equipment themselves. That's been done by, right now, the biggest company would be Ericsson. That allows them to get where the radios come from. Now, they might get antennas from other providers. There's a lot of antenna companies out there. But in terms of the software that actually runs their whole network and allows them to troubleshoot and measure everything and automate everything, they're going to go with Cisco, Ericsson, and other big name, well-known companies. And it's incredibly expensive to license it, to procure it. All that network equipment, extremely expensive. So the idea that they would actually share their network with somebody who's not an engineer, with a group that they don't have direct control over, I think is just completely the opposite of how they've done things forever. I mean, they really started going in the mid 80s is really when they first started coming up in major cities. And I just think that it is so radically different and transformative. It is something that would normally never come out of the telecom organization. It's so innovative. I think it really puts them on their heels and also threatens their relationships with some of the manufacturers and suppliers that they work with today. So I don't think it would get very far at all inside of a carrier. But outside of it, where we're at with Helium, it's a whole different game, because now it's like, okay, they really pay attention to reducing cost. And if the cost can be reduced significantly while not losing quality, it's like a no-brainer. We're going to do it. Why? Because we're going to get a better return. We'll be more profitable. We'll return more to our shareholders. It wins on the balance sheet. It wins for the business.
So why is lowering costs so important? Has this always been the center of carriers' attention, or is this a problem that's brought on by newer technology where the capital expenditure is now higher and they need to lower costs?
Yeah, so that actually touches, I think, on a bigger issue in the telecom industry. The costs are going down. They can buy at scale. They can negotiate very harshly to get the prices that they need to hit. That's not the issue. The issue is that for them is the value-added services that come on top of it. And this is kind of the tug back and forth between the tech industry and the telecom industry. They both believe they own your cell phone. So they both think that we should make all the money when you use all the cell phone. We should, for instance, ads, retargeting ads. They would love to swap out the ads with their own ads and say, okay, we're doing it. You've seen a lot of things over the years with tracking cookies, tracking users where they go. Why? Because that data about where you're going, what you're clicking on is extremely valuable for marketing and for sales for companies. And selling that data makes a lot of additional revenue. The big thing with the carriers is that they don't want to be just a big, simple pipe. That's not a profitable business. They want to have value adds. So back before we had smartphones, it was things like getting directions, getting fancy ringtones. There were all these additional ways to get revenue from a cell phone. Now it's more like there's more and more pressure coming in from the tech industry. We'll give everybody that for free, and we'll encrypt everything so you can't retarget them, you can't track them as easily, et cetera. You can't see all their DNS requests now. So that has been a big thing that putting a lot of pressure on them. Find other ways to become more profitable. And we've seen them try a lot of different ways, both AT&T and Verizon. Verizon had several initiatives, trying to offer video as a service out there in things like there was Redbox on Verizon. There were several other initiatives where they would say, okay, we've got this extra service. We're like YouTube, but a different version of it, where you can rent and watch movies through us. You don't have to go to Hulu and go through Netflix. You don't have to go with the bigger, well-known tech companies. We have our own alternatives. Similar with AT&T. However, we've seen over the past couple of years, a lot of those initiatives haven't gone very well because, in my opinion, they are really, really good at running networks. But when it comes to like social media and engaging audiences and entertaining them, it's just a little bit, it's a much different skill set and requires a different focus of the company to come in and do that and execute on that profitably well. So that is why they want that data transmission to be reliable, but also affordable to them, because the cost of putting, a gig of data through let's say a Helium LTE antenna setup that someone has set up at their home on a roof, they're basically free bandwidth. So the Helium network could price it extremely competitively to Verizon's internal cost to deliver a gigabyte of data, to the point where it's more profitable for them to work with Helium because it is at a price that they just can't touch. On a high level, that's what really matters, is we've got to be able to, there's basically an insatiable hunger from these devices for more and more bandwidth, for more and more data everywhere as cheap as possible. And the thing is that the carriers do, there's another part of it too. What do they do that we don't do? They do customer service. They have retail locations. They work with billing. They do all that endpoint kind of fuzzy human stuff that, you don't really want a crypto network doing with grandma. So it's better for them to kind of handle the fleshy human stuff of stores and people and talking. They can do all that customer service kind of work, but on the back end, we can invisibly be an extension of the network at a very competitive cost, and as well, as long as the performance works out as comparable to what they have now, which I think is possible.
Yeah, a lot of those quote unquote value added services that you mentioned, I remember when they used to be prevalent, right? That the Verizon navigation or AT&T navigation or whatever, there are so many different services and they're all so terrible. I mean, even now it seems like they've given up and they're just bundling other services like Hulu and Netflix and whatever, depending on which carrier you choose, because they know that they can't do those services well. And of course, the tracking and the data selling. I mean, most people don't know that because of the nature of cell service, that you're connected to a macro site that is near you or a small cell that is near you. Your phone company knows who you are and they know where your cell phone is at all times. They can triangulate pretty much where you are at all times, and they can then sell that location data to advertisers who want to target you more accurately based on your device's IP address, right? Your carrier has all of that data. I mean, I recently learned that for my carrier, I have to go into some really deep buried dashboard just in order to disable certain permissions for them to track and share my location, my IP address, and give me, quote unquote, enhanced targeted ads based on all of it. I'm sure 99% of people don't even know that that stuff exists, but it's a huge source of revenue for the carriers. This cost reduction is kind of part of the acknowledgement that they're not going to be able to milk that stuff forever, right? They're going to have to eventually become what they detest, which is the dumb pipe, who just is a network for sending data. All the services on top of it, all that revenue is extracted by some third party who they can maybe partner with to, refer some customers or whatever. But at the end of the day, their main competency is building the physical network and is also servicing the customers and having those relationships, especially with the less tech-savvy users, that they really need those in-person, on the phone, supportive relationships in order to keep those people as customers.
Yeah, I mean, a lot of people come in and say, why would you pay more for Verizon and AT&T? Because it's a better service. That's why. So that's what really matters to people. Better customer service, faster speeds, more reliable speeds, are all really important things that come out there. However, I would argue is if it's a competitive industry, the speeds, the technical aspects should equalize out to a certain point where they're hard to distinguish with similar investments. And then you start getting into, how much spectrum they have, how many radios they have. You start getting into the technical details of, having more radio resources so the phone can talk more and transmit more data back to cell sites. But yeah, you're absolutely right. those value-added services that they had and extra apps, all the stuff we paid for, like in the early 2000s, it's all free now, and you would never think of paying, $10 a month for it, or something like that, or paying a subscription for a ringtone, But and I remember VZ Navigator was a huge app back before Google Maps. It was probably the best turn-by-turn navigation you can get, but it wasn't cheap. You had to pay a healthy price for it. So there's a lot there, and I think they're always going to have people's navigation data, location data. It's just how the service works, and that's going to be it. And the tech companies have kind of said, we own media. If you want Hulu, HBO Max, which is what people actually want to watch, they've been forced to bundle it versus create their own competitive services that were out there over the last 10 years, but media services that didn't do so well. So that's why I think the motivation for them to come to the table and say, yes, we want to try this. We're going to try it out. And I think it only takes one, either Verizon, AT&T, or T-Mobile/Sprint, to come to the table and say, we're all in. We're a partner. You can use some of our spectrum or a CBRS spectrum with compatible handsets. We want to offload as much as possible because we need all the bandwidth we can get, the data we can get, all the coverage we can get, and this will give us an advantage. And as soon as the first one does it, I think the rest of them will just will come on board very quickly.
Well, we know from Freedom Fry CEO Boris Rensky's recent FAQ that one of them is currently in the integration phase. So if your theory is right, we're going to have all of them. I hope you're right.
Yeah, I definitely think we will. I saw the answers from the Q&A. They're pretty serious. I'm very excited about it. It's the biggest. I think it's for people like me who are very excited about telecom and decentralizing it, bring down the cost and bring it to the people and sharing the revenue. It's just it's very exciting. But like everybody says, you can't hurry up, having a baby. It comes when it's ready. So fingers crossed it comes.
That's right. What's the analogy? 9 women can't make a baby in a month.
Exactly. Yep.
It's one of those things you never think about until you do think about it. And then you realize, wow, there's no way to speed certain things in life up. So let's talk about the cost reduction. The carriers are very insistent on having a low cost of providing service to each customer. And they measure their cost per gigabyte. I've seen estimates that it costs a carrier between $2 to $5 per gigabyte to offload onto towers they don't own. And of course, a lot of what happens in cell service is you, with your carrier, roaming onto another carrier's tower that your carrier does not own, but has a agreement with that other carrier that their customers can use the tower, and your carrier pays that carrier per gigabyte in order to access the tower. Now, I've seen estimates that that's between $2 and $5 a gigabyte typically. The proposed rate that has been approved through HIP-27 for the Helium network is 50 cents per gigabyte. So that is 5 to 10 times lower than what the carriers are getting. Now, if you look at why this is possible, it makes a lot of sense. And you said it earlier, soft costs for deploying Helium 5G hotspots are so low that they're able to undercut the carrier's own cost of deploying their own network. Because with Helium 5G, you have a hotspot that's using existing land that the hotspot deployer probably already owns or has access to, existing power connections, existing internet connections, and the time and labor of the hotspot deployer to deploy it and maintain it and invest in the initial equipment. When someone deploys a 5G hotspot, they're looking at upfront an investment in the thousands to tens of thousands of dollars, but from their perspective, that's about it. They are already paying for all of the other things that are necessary to deploy the 5G hotspot, depending on how they choose to deploy, like if they want to deploy at home or in a commercial location that they already have access to. So that is what allows that cost per gigabyte to be so low. And then at that point, once it's deployed, that 50 cents per gigabyte for the Helium hotspot owner is very profitable. And for the telco is also very profitable because they're saying, wow, I can serve customers in this small spot that had no coverage before. They get a positive impression of my brand because they are getting service somewhere that they wouldn't otherwise, whether that's an underground bar or a rural area that's served by Helium 5G outdoor antennas. And the carrier gets to become more profitable in the process. It is very much an everyone wins situation. So is that why you're saying that, you think that all the carriers are going to pile on because there's almost no downside for them?
Yeah, that is the main reason why I think they're going to pile in, yes, is because the economics can't be beat. It is so efficient to simply pay by the gig instead of pay all those fixed costs and recurring costs for equipment and staff. The only thing I'm sure that they're nervous about is the quality of it. So to make sure they don't interfere with each other, because that's where they spend a lot of work. But the bigger kind of elephant in the room is going to be saying, I want the coverage, in certain areas. And they could even, if they wanted to, they could open up a little bit, share some of their performance data, and actually say, I need more Helium offload in these areas because you'll make X amount per month based on our projections. If they wanted to really open up their numbers, they've got the data. And they could say, we need you here. And people would come, I'm sure people would come flying in and saying, well, even though it costs $10,000 to get a host, get a dedicated internet connection, and get the equipment, I'm going to make that back in X months. And for a business decision, I'm going to get better than I get the stock market, better than 4% or 10% or whatever. And, I'm going to deploy there if I can. I think people are naturally going to figure out where to put hotspots, which is mainly going to be downtown and highly congested areas and indoor areas, and start deploying them there.
As we're on the topic of cost, I want to talk a little bit about a cost that we've been mentioning a little bit, but kind of shying away from, which is the spectrum licenses. This is the main cost in deploying any cellular network. If you read any telecom publication, you'll see that there are these spectrum auctions that happen routinely. And these are basically auctions by the FCC to buy licenses in order to legally broadcast in certain areas of the country. Usually they're spanning the entire country. But of course, these licenses are purchased piecemeal. But you'll see the big carriers bidding literally tens of billions of dollars to get countrywide licenses for certain new frequency spectrum that is opened up because it is now unused. It was previously used for something else, or just its previous license has elapsed and now there needs to be a new auction. So this is an incredible source of revenue for the FCC, for the US government, just selling these licenses. I want to talk a little bit about the big picture of Helium 5G. We've talked a lot about its purpose, like where it can fill in gaps. I really want to touch on why it can even exist. And you brought this up earlier. You said the miracle of CBRS. Anyone who has read about it in depth and studied what CBRS is, it truly is a miracle. Like, it's almost entirely unbelievable that it even exists. It is something that only exists in the United States. As far as I know, we are a leader in this space. And basically what it is it's called shared spectrum, where there is an open license that anyone can use to broadcast within this band as long as they follow certain rules, kind of like how 2.4 gigahertz and 5 gigahertz work for Wi-Fi. But in these bands, you can transmit cellular data signals, which is completely new. Like, there is nowhere really on Earth where you could just go and deploy your own cellular network because of the simple fact that there is no license available for individuals to do that for free. CBRS is this miraculous thing where instead of the FCC making another few tens of billions of dollars selling spectrum licenses within this range, they've decided to open it up. I think from their perspective, they see that it could enable so much innovation that it's actually to the benefit of everybody to just have this open spectrum, which does have certain rules and is shared with the military that you can, get deep into the caveats of CBRS. But this is what allows Helium 5G to even exist. Without CBRS, there is no Helium 5G. With the free nature of CBRS, this is the way that Helium 5G can undercut the carriers on their offering. The spectrum license, which is the most expensive part of the whole thing, is just free. And I don't think it can be overstated how significant that is.
It's huge. And there's one add-on that I'll add to that. Also in March of last year, they also added an addendum statement that actually supersedes any HOA in the organization that gets in the way of deploying communications equipment. So that's another plus. So if, a lot of people talk about this on the community, about complaints about your antenna's ugly or too high or whatever, as long as it's used for broadband communications, it supersedes any local regulations. You saw this also with small cells because a lot of cities were blocking small cells. FCC came in and said, well, you are allowed to object to it and plan for it, but you can't just block them, all of them. You have to approve them. You don't have a choice. And we're seeing the same thing with deploying telecom equipment, also from the FCC. They're very, very pro deployment of connectivity. And so, yeah, it's a huge gift to the USA to do this. And I think that hopefully over the next 5-10 years, it makes us to have, we're a little jealous of, let's just say it, we're a little jealous of the broadband prices and connectivity other nations have. Like I'll mention like South Korea. Everyone's got broadband, everyone's got a gig. They're like, a gig is nothing. And right. Another thing that I'll mention is I always keep an eye on the future, on the big picture. Let's look forward to 6G as well. Right now, some news came out today about some testing that they're doing. 6G is planned to have a maximum data speed of 1 terabit per second to a cell phone. Right now in the labs, they've confirmed they can hit, now 5G, with line of sight, you can hit a gigabit. So, but that is a huge amount of data. How are we ever going to have that much available? So that's a bigger challenge that I think we need to work on for the next couple of years. Even if we deploy out all these cell sites, what about the next generation? How are we going to be able to get terabit speeds to people's houses and to all these hotspots all over the nation? I think that's going to be really interesting to watch for the next couple of years.
Definitely. I mean, global data demand is pretty much just a curve up and to the right? It's just an exponential growth curve that never goes down. It seems that no matter how much new capacity is deployed, it is in time, in a matter of years, met with maximum saturation of that capacity because we discover new things to do with our phones and new, applications, or just, making existing applications better, like clearer video calls or whatever. This stuff all uses more bandwidth. So the demand for wireless bandwidth is basically up towards infinity forever. Let's talk a little bit about the opportunities and risks for people who are interested in deploying Helium 5G hotspots. I'll just say right up front that there is no chance that you're going to earn anything deploying a Helium 5G hotspot in at least the next 3 to 6 months, because there's integration going on the back end to enable the telcos to pay into the Helium data credit infrastructure. So that is currently what's holding up earnings. So no one's going to be earning anything anytime soon. But the big picture, like what type of deployments are we going for with Helium 5G? How can we maximize our utility? It's clear that we are not, as of present, building our own first-party 5G network. We are filling the niche of offloading the big carriers. Like this is the most important thing for Helium 5G hotspots to do right now. And it's something that we can do that fits in extremely well and creates a symbiotic relationship with the carriers, which has all sorts of benefits. For someone who's looking to deploy a Helium 5G hotspot, what do you recommend that they look for in terms of setting, where they're deploying it? Are they going to be able to compete with what the carriers have out there outdoors, or should they just stick to indoors for now? What are your tips for someone who's interested in getting into this?
Yeah, so here's what I would do. And I would agree, that's for the crazy visionaries like me spending thousands of dollars on radios and equipment that currently makes me zero and will likely make me zero for several months to come. But that is okay because I'm an enthusiast. I love this stuff. I love getting into it. So what I would do is use apps like OpenSignal and look for where there's poor coverage, especially near big areas. So I know of many, many communities. I'm here in Wisconsin, many, many places that are starving for 5G coverage and 4G coverage today. Why? Because they don't allow the carriers in on their macro cells. They put their small cells in, but not the macros. So look at OpenSignal, look at the speeds, look at the coverage from the current carriers. You're going to find these little niches, these little areas to where coverage is not that great, but there's a lot of population or a good amount of population. That'd be a good first strategy to do spots. I can tell you right now that I already have a waiting list of people who want me to put those up at their house because they are starving right now for high-speed data. The coverage sucks. They want more speed, and they get to make something on the back end. They love it. They just want to do it for better coverage. I got people who have like vacation houses who are like, dude, I'll pay you to put one up because I have such bad service, in this vacation community or in this RV park. Like I think the biggest there's a lot of opportunities out there. I think right now, if you're smart, you're getting very aggressive in locking in hosting agreements to where you want to put these up. Exclusivity agreements or revenue sharing agreements, which is what I do, is revenue share. So to get those spots, there are very valuable spots right now to go after that are really obvious, that are underserved, that basically have unlimited data demand. Think of parks. Think of places like that. I'm not going to let them all out of the bag, but there's a lot to think of. I would talk to them now. I already have a waiting list for when equipment is ready. On the flip side, I don't think equipment is going to be ready this year. I don't think we're going to see a lot of any 5G antenna availability until next year, just because right now we're in the lunar new year, or the lunar Chinese year, so everything shuts down every year. But I just think that with the lockdowns happening in China, it's completely still causing massive manufacturing delays. I would plan and lock in where you want to put these, and only put these on those locations where you think you're going to make a lot. This is not like Helium hotspots where you might want to take a little gamble and say, oh, well, this spot looks pretty nice. I think they're going to make over X amount, which is, whatever your minimum is, or maybe you don't have a minimum. You may not want to make that same gamble when it's a $10,000 piece of equipment to just put it out there. That's where I would focus on. So use open signal. Think of major areas that have huge internet demand, like parks, vacation areas, especially even seasonal areas for big events. Think of fireworks shows. Where does everybody go? Things like that. Think of where concerts are at. Maybe you can just be just outside the concert. Because for all of the, here's another thing in the industry I'll share. There's terms we call colt and cow. It means sell on like truck or sell on wheels. And those are where, for special events, all the carriers roll in actual trucks and they put up temporary cell sites to cover that event, because they know that there's going to be so many people there and so much demand. They're going to get complaints if they don't, especially if they sponsor whatever that event is. So they bring in trucks and actually wire up fiber internet and put it up, because they don't want to get complaints. Because they know if they get complaints at a big event, customers go to the other carrier. They're like, oh, I'm on Verizon. Oh, Verizon sucks here every year. I'm going to go to AT&T. Oh, AT&T was good. Oh, now it sucks here. I'm going to go back to Verizon. So there's a lot of that happens going back and forth, or I want to go with T-Mobile. So that's what I would be thinking of, is deploying to those areas and locking those in as soon as possible. Those are the biggest opportunities. And even at a crazy cost of $10,000 or $5,000 or $2,500, I think these agreements are going to go through. You are going to end up, if you get anywhere close to the current number that's been agreed to, I don't see how in the long term, meaning a year plus, they want to pay for themselves with a decent deployment. I'd be more worried about getting the locations and actually having enough data. Like, you're going to need, to really max out some of these. Most of them, I was looking at the base cell spec sheet, and really it maxes out at about, 520, 530, 560 megabyte. Think to yourself, is that something I can actually support? Like, in my backhaul, do I actually have internet that can go that fast? Because even though you have a perfect deployment in the right spot, maybe limiting yourself by how much data you're actually able to send off. So I think that's going to become a bigger and bigger issue with 5G deployments and onto the future of 6G when it gets here.
So my plan of sending a balloon with a Helium hotspot into Coachella with a fiber line hanging off of it, I'm basically going to be a millionaire, right?
Oh, man, if it can handle the data. Oh, man, don't do yourself a favor. Don't look at the Facebook groups for cheap Helium installs. There's a lot of nightmares on there that are like that.
Oh, God. Yeah, we're definitely targeting more of the highly motivated / professional crowd with this 5G stuff. As you said, I think you said it really well. It's just going to take a lot more time and effort and placement, and there's going to be a lot more to think about as opposed to deploying LoRaWAN hotspots. The backhaul requirements are different. The power requirements are different. The placement is different. The amount of coverage you can provide is different. And the upfront cost is just much, much, much higher. All that paired with the fact that, as you also referenced, the carrier agreements aren't there yet. So, even if you do deploy now or in the next 6 months or a year, until those carrier roaming deals are not only signed, but fully integrated, I think that's something that people don't think about. Just because a carrier deal is announced does not mean the integration is done, right? Dish was announced months ago, and it's still going to be months until you can roam from Boost Mobile onto Helium hotspots. And it's going to be months until you can earn anything. There are a lot of unknowns, but from what you're saying, I can understand that the known factors of what a good location will be is actually much more certain than LoRaWAN, because you have this existing install base of devices. So if you make the assumption that all the carrier deals are through and everyone who has a phone in their pocket can talk to your hotspot in any given area, it's actually very straightforward to determine what the best areas are. So for anyone who's enterprising out there, you can really start taking those first steps in finding your areas, maybe doing some surveys. One day, the carriers will release their own reports, because I assume that they spend millions or tens of millions of dollars surveying their own networks. and then finding where their so-called soft spots are where they don't have coverage, right? An ideal future that I see is that carriers are openly sharing this data, and people with Helium 5G hotspots and time and resources are going to be out there filling in the coverage. And as someone who lived in an area where there was no coverage when I was a teenager, it was extremely frustrating. Like, it was a legitimate quality of life decrease, and all we could do is beg for them to fix that. And we couldn't even get them to send us, a little microcell that we could host for free at home that would at least give us coverage in our house, let alone get paid to do that. I think this is going to be a very attractive option for the people who, as you said, are just starving for coverage right now and can't get the cell companies to do anything about it. The rest of us are out here in our always connected world, but there are millions of people out there who are legitimately suffering because they cannot get a good cell phone connection or a good home internet connection, which could also be provided by Helium 5G.
It has a big impact on people's well-being. And I'm just thinking of, I'm trying to work with some communities in Milwaukee and Madison. And I think if you deploy this to an area that's underserved, the revenue share, not only for that location, could change their life, but for that entire area to now actually have reliable service is a huge boost. It's very exciting in the long term. In the short term, we're figuring it out.
Yeah, definitely. And I do love how the revenue sort of goes back into communities instead of, going into AT&T shareholders, right? Share buybacks or whatever, because you're essentially taking that money that's being paid already to the telcos, and that's going into Helium data credit burn and going into the pockets of hotspot hosts. That is kind of the Trojan horse effect of Helium 5G. That existing money that exists completely outside of the crypto space is sort of being beckoned into the crypto space and into the Helium network token. It's a fascinating experiment. And, you could imagine that long term, this could be like simultaneously the best and the worst decisions for carriers, because they could end up funding the structure that ends up dismantling them if, 1,000 things go right. There's a long way between here and there, but it's a very interesting scenario of like, damned if you do, damned if you don't for them as they are looking to deploy more low-cost coverage.
Yeah, I think as a profit-driven corporation, it will draw them in and eventually, I don't think we'll ever get rid of the carriers, but I think it will allow them to be more efficient with the resources that they choose to spend on deployment considerably. And if they, I'm waiting for a carrier to stand up, who knows who it will be, and actually say, we're not just going to partner with Helium, we're going to promote it. Like, we're going to be partners. We're going to share data with you. We're going to help you grow. There are areas where you are a perfect solution and we need you there. There are other areas where we don't want you there because we don't want you polluting the RF. We want to have our macro cells and small cells take care of it. So that's the real interesting part.
Well, it's a really exciting future. I can't wait for it to play out. I'm sure we could cover so many more subjects, and I'd love to have you on again in the future to go a little bit deeper. But I think this was an awesome high-level overview of sort of how the carriers fit in with Helium, what they're feeling right now, what their pain points are. What is the opportunity here? This subject is so deep, right? The subject of cellular service and 5G. Of course, in an hour, we can only scratch the surface. But I hope that people will submit their questions to me if there are more topics that you want to see covered and you want an expert like Russ to answer them. I think we're both open to, taking in your questions and just answering them as much as possible. And I'm sure I'll have more of my own questions as I digest the information that I've taken in today. And from other conversations we've had. Russ, thank you so much for coming on. I'm really excited to get all this information out there.
Likewise, I appreciate you having me on. I'm so excited about the community and what we're going to do. I'd love if people would send questions. I'm an open book. Feel free to ask anything you want.
And maybe we can do a Twitter space soon where, because that's actually where we met. You hopped in on one of my Twitter spaces and you were just answering questions, firing off like crazy. And I was just like, I'm just going to let this guy talk for like as long as possible because he's saying amazing stuff. But maybe we could do more of those sort of open Q&As, and I will get better at recording that stuff and putting it out so that people can hear it if they weren't able to be there in real time.
Sounds good.
Awesome. All right, Russ, thanks so much. I'll talk to you soon. Take care. Thank you for tuning into The Hotspot. If you love our content, don't forget to subscribe on your favorite podcast platform. And if you want to maximize your impact, leave your honest review on Apple Podcasts. Your support helps us reach more listeners and educate them about the Helium network.